All right, so I'm going to walk you through the lesson for this week on section 8.1 since I won't be here. And I am going to start by talking about confidence intervals. And we're going to learn about the basics in this section. Next week, we'll build upon this and talk about it in terms of proportions. So, what you're going to need to do is get on the agenda for this week, which you'll see here. And you're going to need to open up this mystery mean activity. Once you have this open, you are going to click on the random number generator link, and that's going to generate a random number for you from 1 through 2 to 20. No, it doesn't matter. 2. My number's 2. So I'm going to come back here, row 2. Those are going to be the scores that I use. So I'm going to find the average of those 5 scores. I don't know this off the top of my head, nor do I really want to take the time to do this. Equals AVG average of 92, 82, 85, 82, 78. All right, 83.8. Sorry, I had to sit through that. Okay, so back to your lesson. All right, the scores, you can write down the scores. This is a typo. It should say 5 scores, not 4. So actually, why are we even doing this? Hit the brakes. So the big idea is we're going to use intervals of plausible, and we'll get into that, reasonable values to estimate the value of a parameter. So if I want to know like what percent of Rush Henrietta students have hazel eyes, I'm going to come up with an interval to estimate that parameter. Maybe it's really 5% of RH students, but I don't know that until I construct a statistic from a sample and then generate an interval. So what we're going to do today in this activity, I already started and didn't even tell you what it was making your best guess at the mean of the midterm exam for a group of my students a couple of years ago. So we're going to create this thing called a confidence interval. You take what's called the point estimate plus or minus the margin of error. Margin of error is a term I'm sure you've probably heard before. There's no prize. I'm sorry. The prize is just watching me on camera right now. All right, so your scores, whatever the scores were from the sheet, and then the average score. So you saw me calculate the average score for my randomly selected 5 scores was 83.8. That is my point estimate. So right now, that's the best estimate I have for what the real mean midterm exam score was. So the population would be all the midterm exam scores. Just for my class in that specific year, my classes, the sample would be the 5 selected scores. The parameter would be mu, the true mean midterm score, or the population mean midterm score, and the statistic is X bar, which is your sample mean midterm score. So what is your best estimate for the real mean? I mentioned this just a minute ago. So think about that, see if you can fill that in. The best estimate is our point estimate. So for me, it's 83.8. For you, your set of data could be different. Most likely it is, but it's the average of your 5 scores. Moving on to the second page here. Now we're going to change this point estimate into an interval of values. And the way we do that is by adding and subtracting the margin of error. So to do that, we need to calculate the sample standard deviation. So I'm going to do that on the calculator. So let's see, 92, 82, 85, 92, 82, 85, 82, 78. All right, so let me show you what I'm actually doing. All right, here's what I'm actually doing. I plug these into a list. Then I'm going to go to stat, calculate. I'm going to do one variable statistics. On list 1, I want to delete anything if there's a frequency list and just go to calculate. So This came from a sample. This came from a sample. So I'm going to use the sample standard deviation S, not the population. This was not a population. So I'm going to use this 5.22 approximately. Oh, to the nearest tenth, 5.2. Okay. Now to find the ME, margin of error, I'm going to multiply the standard deviation by 2. Why? Because we want to capture about 95% of all these sample means. So 2 times the 5.2 is 10.4. So my margin of error for this set of data is 10.4. Yours is going to be different, most likely. So to help construct this confidence interval, what we're going to do is add and subtract that margin of error from my point estimate. So 83.8 plus or minus 10.4. 83.8 minus 10.4 is 73.4. Plus 10.4 would be 94.2. 94.2. That is my confidence interval. Go ahead and write that on the board. Just kidding. I'm in a silly mood. So that's your confidence interval. Based on your confidence interval, I have this claim. I'm like, hey, I think the midterm exam score, like the real average is 98.3. Do you think your interval, not mine, yours, does your interval support my claim or not, and why? So why don't you pause the video here and try to answer that question? Okay, for me, it's literally, does 98.3 fall in this interval, yes or no? It does not. So my interval does not support it, and if anything, it goes against this claim because, what is it, 73.4 to 94.2 does not include 98.3. I don't care if 98.3 is just in it barely or like right in the middle. It's either in there or it's not. It's that black or white. That's how you need to think about it. Okay. So let's talk big ideas for a minute. We just came off of chapter 7. In chapter 7, it wasn't really reality. We were kind of laying the foundation for the work that we were going to do for the next few chapters. What do I mean by that? In chapter 7, we knew facts about the population. We knew the parameter value. And then they asked us, could these results happen in a sample? All right. In reality, we're not going to know about the population parameters. Otherwise, why would we ever take samples? So in chapter 8, now we know facts about the sample, and we're going to ask, could these results happen in a population? So we're going to be estimating these parameters. So the reason we use an interval of values instead of just this single point, because we're going to be a lot more confident with an interval. So I'm going to be a lot more confident saying, you know what, the real mean midterm score is somewhere between 73.4 and 94.2, instead of saying, I'm absolutely certain the real mean is 83.8. It gives us a little bit of variability there. All right. Okay. So this first learning objective talks about determining your point estimate, I'm just checking time, and the margin of error from a confidence interval. So here's the deal. A point estimate, that's just the best estimate we have for the population parameter. And we just calculate it from the information in the sample. It could be a sample proportion, it could be a sample mean, it could be a sample standard deviation, a sample median, a sample IQR. It's just, we're estimating the population proportion with the sample proportion, the population mean with the sample mean, et cetera, et cetera. So how do you actually get the point estimate if you're given an interval? So say I have some interval A, B. Obviously, there are going to be numbers in the problem, but to get the point estimate is just right in the middle because you're just adding and subtracting the margin of error. So to figure out the point estimate, I'm just going to do A plus B divided by 2. The margin of error, it's just the distance between the min and the max divided by 2 because you're adding and subtracting that value. So in this check your understanding, what I'd like you to do is pause the video here, read through the question and answer part A and B, then come back and take a look. How much fat content in brand X hot dogs vary? To find out, the researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation is 2.84 to 7.55. So that's the confidence interval. So you can think of this as A, B. The point estimate's right in the middle. So I just need to find the average of these two numbers. So it's going to be 2.84 plus 7.55 divided by 2. That is 5.195 grams. That would be the sample standard deviation because we're trying to estimate the population standard deviation sigma. So we'd be estimating it with S, the sample standard deviation. Margin of error, I just need to find the difference between these two and divide it by 2. Why am I dividing by 2? Because I'm adding and subtracting that difference from the point estimate. So 2.355 grams would be my margin of error. So hopefully you found some success on that, and that was pretty straightforward.